Welcome, my name is David Hayes, and this is Introduction to Linux slash Unix. First thing we're going to do is we're going to go over the syllabus. Now this is Blackboard. If you've never been in Blackboard before, you'll have to go through an orientation, and it's possible that everybody has to go through the orientation. So if you're going into Blackboard and you don't see the course yet, that's the reason why. You have to finish the orientation, answer all the questions, and then it'll let you in. Once you're through the orientation, you should have a line item for each class. So you click the Introduction to Linux Unix. There's a link here that says Start Here. This is where the syllabus is located. See the Introduction to Linux, CIS 1908 syllabus. Download that. Okay. And I'm not going to sit there and cover all these items. You can obviously read and so forth. My phone number's there. It used to be I tell people not to leave me a message. Hi, Jesse. If your volume is... Hi, Jesse, can you hear me? Okay, good. I was just getting ready to write your note there. I just started out going over, getting ready to go over the syllabus. Okay. Okay. My phone number's there. Used to be I'd tell people not to leave me a message, but since I moved to the Sumner Center in Wellington, my phone appears to be working all the time. It used to be when people leave me a voicemail, a little light wouldn't light up to let me know I had a message. But it looks like that's been corrected. So I feel 100% confident at this point that if you leave me a message, a little light will appear. I got my email address here, but all communication should go through Blackboard messages. If you send it to my Kali account, it might get lost with some of I get tons of junk emails each day. And, but Blackboard is very specific to the course material. Office hours, I haven't got approved yet. But if you find that you need extra help, you just let me know. And we'll figure out a time when I get on and help you through the material. Expectations of the course, it's 100% online, but I'm going to be holding these sessions every Tuesday and Thursday to cover material and kind of give you the same experience you would in a regular classroom. Let's say I'm going to sit here and read all this. This is mainly all the standard stuff that goes with every online syllabus. Oh, okay. Late word, none will be accepted. I will drop the lowest item in each category, excluding the final exam. Textbook. This is the CompTIA Linux Plus Guide to Linux Certification, 4th edition. This is available via MindTap, and we're going to go over that much more next time. They got the software or the MindTap software working last night, so I'll be able to add in some items today, and then on Thursday actually sign the first material out of it. You don't have to buy anything. It's figured in with your student bill. So if software comes up and asks you to purchase something, don't do it because it's included. Let's see, course grade, lab simulation is 25%. Live virtual machine labs, 25%. Quizzes, tests, 40%. Essays, 10%. Now, part of this is just learn Linux, which we'll talk a lot more about Linux shortly. But it's also, this material prepares you to take the CompTIA certification. And no matter what your grade is in the course, if you take and receive your CompTIA certification in Linux, you'll receive an A in the course. So that's kind of considered the gold standard in certification. You'll see a lot of prep classes for various certifications. There's CompTIA, there's GIAC, there's a has some. And get a lot of feedback there. Okay, and you can take the prep classes, but it's not that meaningful without the industry certification. So that's kind of the key. I'd definitely recommend after you finish the course or toward the end of the course, you go and take the certification. It looks good on a resume. It shows that you not just took a prep class, but you actually knew the material. Let's see. Then they got a schedule down here. Then down here at the very end is preparing for the certification if you're going to take that. It's not required; they're not free. Take the test, but I definitely recommend it. Now under course content, you'll see a red shelf portal, and that's where you'll get the code for Cengage. And I added this in, like I said, they got working last night, so I added this in, but I haven't really got too much of a chance to experiment with it, but it's got the ebook built in. It's also got the virtual labs and so forth, and I'll go over more of that. The Zoom class meeting link is right here, and then for each week I'll put a new folder out, and within the folder will be the YouTube recordings. So I'm recording all these lectures. It will also contain the assignments, or tests and whatever other graded activity is for the week. Well, let's start talking about material. I like questions, by the way. If you have any questions at any point, stop me and I'll see if I can answer them. Don't know everything about Linux. It's quite a diverse operating system, as is Windows. This is Introduction to Linux, Chapter 1. Our objectives: explain the purpose of an operating system, outline the key features of the Linux operating system, describe the origins of the Linux operating system, identify characteristics of various Linux distributions, where to find them, and explain the common uses of Linux in industry today. It used to be that the reference to Linux was not common. It was referred to as Unix, as the Unix operating system. And a lot of education used Unix to begin with. And then they started realizing the power behind it and some of the security behind it, and they started using it for other purposes. I suppose my first real experience with Unix was a free BSD distribution. The company I worked at, IFR Systems, they wanted the intranet, and so I set up an Apache server running on the free BSD. And my goal was to get front page extensions. Front page was a Windows product that would publish web pages to your internet. My goal was to get the front page to publish to the free BSD and so forth. So I had to get the extensions working. Well, first off, it was a challenge to get the Apache working. Apache what runs all of your web pages and so forth. There's a lot more to it than that. But I got that working. I think I ended up buying an O'Reilly book. Helped me get that going and getting all the configurations correct and so forth. Then there was no book for front page extensions, getting those working. So I was working off of what information I could find on the internet at that point in time. And I think I spent a week trying to get that to work. I was never so frustrated trying to figure something out because I didn't really have anything to go off of. I was trying to find stuff on the internet, there wasn't. It's not like now where you can go and get 50,000 hits when you are looking up an item. And so finally I went to my manager and I said, can I call Microsoft? And it wasn't free. She finally relented. I think I got to the begging point. I could probably easily spend a year on it and still not have a solution. And Microsoft got me working probably in 20 minutes. I'm just guessing the time now. It wasn't very long. And then I asked them a bunch of questions too, because I wanted to know kind of the history of front page, if I should even be using it, because I said, you know, maybe I shouldn't even be trying to use this Windows product talking to a Unix server. And they told me that originally a front page was a Unix software package. So they said they're actually meant to talk to each other. So that was interesting. It also helped me realize that you need to have a little bit of expertise if you're going to work with these systems. Now, in general, an operating system. Computers have two fundamental components: hardware, physical components inside a computer. You know, your hard drive, memory, all that. Software, set of instructions or programs allow hardware components to manipulate data. There's different types of software. You may find application software like Word or Excel. You may find operating system software that controls kind of the high level of the hardware, controls the application software and so forth. And there's even really low level software that controls the circuits and so forth. So. Hardware components include processor, CPU, physical memory, the RAM. A lot of people don't understand the difference between physical memory, the RAM, and the hard disk memory. The physical memory, I think, is the more important part when you're shopping a computer. I suppose it'd be based upon what your application is. But I find the more RAM I have, the better performance I get out of my computer. Now, there's special kinds of hard drives you can get that really speed up retrieval of information. So that does make a big difference there. CD and DVD drives. I don't know if CD is really that common anymore. DVDs kind of going out in a lot of computers, mainly in laptops, because they're trying to get laptops as thin as possible. And plus, people aren't burning as much to DVDs, software, and so forth. You're downloading it off the internet after you buy it. Flash memory card readers, SD cards, sound card, video cards, circuit boards. Two different types of programs are executed on a computer. You got your application, apps, programs designed for specific use and with which a user interacts. And again, that's like that Word and Excel that I indicated. Then you got your operating system. And it's just code that somebody's written. These the software components used to control the hardware of the computer. Now, it does more than just the hardware. It actually will manage the application software that's running. For example, if I write a program in let's say C#, and I run it, you know what causes it not to take control of the entire machine? I think I have written infinite loops that have taken control of the entire machine. The operating system, in theory, balances that. So it not only manages the hardware side, but also the software side, because they kind of intertwined. You got device driver, software containing instructions that the OS uses to control and interact with a specific device. You got the user interface, an application program that accepts user input, indicating what's to be done, forwards the input to the OS for completion, and gives results back to the user. Can be a command line prompt or a graphical user interface. The what you're seeing here is a GUI, graphical user interface. It's nice. I click this. It's pleasing to the eye. Down here in the search, if I come down here and type CMD. Then it comes up with this, and command line prompt. That's what this is referred to. If I knew some DOS commands, then I could manipulate around the system here. I don't know if I have to have a space there. I think I do. No, I don't. CD ... goes back one directory. CD users goes into that folder, that directory. dir, list files. Lots of different options you could have here. It used to be a program called edit. I don't know if it still exists. Might be remembering it wrong. It's been many years since I was proficient at DOS. This is a command line prompt. And we're going to see in Linux that this is an important feature. You may have heard that Linux servers are more secure than Windows servers. They are. A big part of that is the servers that don't have a GUI, don't have a graphical interface, that are driven by the command line prompt like what you see. When you add a GUI interface, it makes it nice and easy to use. It's fantastic for that purpose, but it opens up a lot of potential hacking. It opens up ports that normally wouldn't be open. So anytime you add that graphical component on there, then it lowers your security. You have to decide if that's important or not. For example, we had a Oracle server, and we had the GUI installed on it. I couldn't even tell you what version of Linux it was, but we had the graphical on there. The reason why is we wanted to be able to easily do various database functions. You might say, well, that lowered your security. Yeah, it did, but our database was just internal, so it was just within the company. Now, if we had it connected to the outside world, that might not have been a good thing to do, because we could have potentially had a lot of people hacking in. So these are things you have to decide. When you're setting up a new Linux server, you add the graphical side. A lot of people use a new one called, or not a new one, but the one called Ubuntu. And if you've ever used it, it's just as easy and user-friendly as Windows. Some people might even argue more user-friendly. Yeah, it is. For the average user, it's great, but you don't want that graphical server set up. You want a command line prompt. This makes it a lot more secure. We had a Linux server at the company where I used to work, and the only place you could log into it was a server, and had this really horrendous password. I forget how many characters. It was like an entire sentence with weird characters thrown in there. 0 for the O. All kinds of variations there. And whenever I'd go and work on that server, they would give me a piece of information with a password on it. I would carry the piece of information in the server, and I'd sit there and I'd type it in off a piece of paper. Not one time could I type it in correctly. Of course, it's not showing me the letters that's on the screen. It's showing me the little, I forget what they were, asterisks or something, where I couldn't see what was input. Here I am with a password on a piece of paper in my hand, and I cannot get into the server. I'd always have to have the Linux engineers come in and type in the password. They made fun of me, of course. But that shows you that hey, if you have your system set up right, and we'll talk more passwords later on, that provides a heavy layer of security right there. Anyway, GUI's bad. The command line is better for servers. GUI's better for users. This shows the interaction here. We've got our computer users, our application software, operating system software, and we got our computer hardware. And again, let's talk about the role of operating system software. Not only kind of manage the users of the system, but run the Word, Excel, allocate memory, and then your down here your hardware. Provide the interface for that, add drivers and so forth. It's been a while since I've taken the Windows operating system class, but part of the role of operating system is to manage that allocation of memory. So when you run a program, that it puts it in an appropriate spot. There's memory that's allocated for your application software, and then there's memory that's allocated for the hardware. And if you put your program in a different part of the memory where it shouldn't be, you can cause your system to crash. So again, it manages all that. We have the graphical user interface, a GUI, component of an OS that the user can interact with using the keyboard and mouse. System services, applications that handle system-related tasks, printing, scheduling programs, gaining network access. And we'll see more about that as the semester goes on. Printing, obvious what that is. Scheduling programs. Linux has a built-in scheduler. So you can run a program at midnight, for example. Windows doesn't have that built in. You can buy programs that'll do it for you, but it's a headache. This has been 15 years ago, and we didn't want to buy one, so we wrote a program to run programs during the night. It was a batch machine that we set up, and used to be we could have a batch machine that was DOS, and the command line worked real well. Windows did not work so well. Sometimes it'd hang up, and we'd come in the next day and see it just sitting there waiting for us. It could be we just didn't write the program correctly, but it's a headache scheduling programs. Linux is anticipated that and have included that software in to do it, and gaining the network access. It shows you a Linux graphical user interface, not much different than what you would have with Windows here. So, not sure why they put "Hello World" in the writer. Now, Linux operating system. Linux, an OS used to run a variety of applications on a variety of different hardware components. Windows has tried to do this to a certain extent. It's been somewhat successful. Linux has probably been more successful. I think I had a brother who bought me a little mini organizer of some sort, Tornado, I think is what it was called, and had a scaled down version of the Microsoft operating system on there. But what happens when you got all these different devices and you want to have an operating system on them? Some of them don't have much memory. You know, can they run a Windows distribution? So Linux will run a lot smaller space in terms of memory. So it gives you more options with Linux on this platform or this device. So it kind of opens up a variety of options. Multi-user or multitasking operating system has the ability to manage thousands of tasks at the same time, allows multiple users to access the system simultaneously. Windows, one computer will allow you to have different users signed onto it. And you'd say, is that what we're meaning there? Well, sort of. Because that's part of it, managing the resources there. But obviously, since there's one keyboard, one mouse, only one person could be using it at one time. If you've ever went on maybe not a high-end computer, but kind of a low-end, and you've had other users signed on, it becomes very slow. The standard Windows operating system does not handle that very well. Now, Microsoft has a server software that will manage multiple users a lot more efficiently. But Linux is just designed with its low memory to better handle those type of conditions. You know, just to show it to you here. Don't think that Windows can't handle a good chunk also. See if I can bring up the task manager without killing the recording. I did a Control-Alt-Delete and brought up the task manager. And you can see these are all the different items that Windows is balancing. Don't know what a lot of these are. Some of them are deliberately vague. System. And what does that mean exactly? Some of these get more detail. You can see the memory used, CPU. This is what an operating system does. It balances all these different items. It helps make sure your performance is halfway decent. Sometimes when, for Windows, you'll find people say, my computers become really slow. Well, that's because every time they installed a new software, they would say, yeah, go ahead and automatically check for new versions. And then to put these little programs out here running, checking for new versions. Oftentimes going through and cleaning this up will fix that issue. There's also, within the Windows operating system, a program called regedit. And what you'll find throughout here is this keeps track of everything. This is kind of your database of a Windows operating system. Of course, this course is Linux. I'm showing this just to emphasize how complex it is to balance everything. All the different items you have to keep track of. Here's all the software. all the settings for Java, JavaSoft, Java Development Kit. You get here, and these are settings. This is telling where it's located at. I could go here and I could change this. Yeah, maybe I can double click that. I could change this and then change the location of it. I break something. Lots of information needs to be kept. Linux is no less complex. Lot of different items to keep track of. Now, luckily, you don't have to be a Linux genius to actually use Linux. Same with Windows. You know, you kind of go at whatever depth you need to. And hopefully, you got a good manager that if you can't figure something out in Linux, they'll let you call and pay for help, as I did with Microsoft. Okay. Thousands of tasks. A lot of people don't realize that because they say, well, I got Word running now, I got IE running, I got 3 items running. No, you don't. You got a lot of different things running. Now, for our versions of the Linux operating system, core component is called Linux Kernel, and this is written almost entirely in the C programming language. You can find copies of this. Not all distributions are available, but some you'll find copies out there. You can change it. Software can be used to modify appearance of Linux, but the kernel is common to all Linux. Important to understand, Linux kernel version numbers decide which version is appropriate for the user needs. We'll talk more about that. And good understanding of system hardware is important in deciding which kernel version to use. Grab a drink here. Linux kernel versions are composed of a major number, indicates a major revision to the Linux kernel. Minor number indicates a minor revision and stability of the Linux kernel. If odd, referred to as a developmental kernel. It says kernel which is not fully tested and with implied instability. Probably don't want to be installing that in your production environment. If even, it's referred to as your production kernel. This kernel has been thoroughly tested, is declared to be stable. You still may not want to be on the bleeding edge of these changes. And then your revision number. Okay, so if I looked at some numbers here. See if I can make that a little bit bigger. There we go. You see we got different numbers here. Now this says 2.5.75. It says developmental. Remember that second number, that 5, is our minor number. If it's odd, it's developmental. The next one down is 2.6.35. So that even number there means it's stable. And they tell you this over here. It says production is stable. You'll find all these with the second number after that, the dot, are even, say, stable over here. So if you're trying to decide what to download and install, that should give you an idea of what not to install if you see those odd ones. Even if something's they say is production, I don't trust it. I almost like to go back one version. Kind of true with anything. You know, I don't want to be the one sitting there with all the headaches, especially if you're in a workplace. If you're in education, yeah, even then it's kind of a headache. We're running Android Studio last semester, and had it running at home. When I got access to the hardware here, I installed the newest version, stable, the production version, and had more headaches. Finally, I went back one version, and it worked just fine. We used that the entire semester. So again, you know, if you want to be the kind of the research type person, the person helping them develop, point out errors and so forth, newest version, then you'd probably want the newest one. But otherwise, you probably want to be back a little bit. our Linux engineers at IFR, they would make a determination when a new version came out if they were going to go to it. Part of it is what did it fix? What did it add? You just don't upgrade just because there's a new version out. You have to have a reason. Why do you get a new vehicle? Your old one's broke. Why do you get a new version? Well, something doesn't work on the old one, so this will fix it. Well, I worked as a computer programmer for 13 years. Yeah, there are fixes for those, but people aren't good programmers. So they fix some items, then they break other items. So there's a risk. That's what I say. Sometimes you just want to wait. Now for our licensing of Linux, there's something called open source software, OSS. Programs distributed and licensed so that source code is freely available to anyone who wants to examine, utilize, or improve upon it. For Linux, you can go down today and download a version of Linux, whatever that might be. You can install it and run it. You don't have to pay a penny. Open source software. You cannot do the same thing with Windows 10. If you try to go and get Windows 10, you'll have to pay a certain amount. You can only put it on that one computer. Maybe 2 or 3, but if you try to put it on 10 computers, you'll be violating the licensing. So open source is it's a fantastic change they made. I couldn't tell you when it was done, when they started doing it, but it saves you a lot of money. Source code refers to lists of instructions the software developer writes to make up a program. This is your computer program you write. And open source means they can see your source. And format and structure of source code follows rules defined by the program language in which it was written. They're going to talk shortly here about what's the benefits of an open source package. Part of it is that you have everybody looking at it, the source code in theory, and so they'll point out your errors. They'll say, hey, this opens up this port right here where people can hack into it. I'm not sure if anybody actually takes the time to do that. Typically, if you're working for a company, you're so bogged down with projects and so forth, you don't have time to sit there and just read source code of a Linux distribution or any open source. Probably it comes into play a lot more if you're maybe a researcher in education, or if you are paid to come up with a Linux distribution. Some people will not go with the open source. They'll buy a Linux distribution that somebody's modified. And the reason why is because they not only are guaranteeing at a certain level that the software will run, but they're also will provide support. And that's important. Like I said, that front page extensions I wasn't sure if Microsoft could even help me very much. I was hoping they could, because it was a Windows product, but I was trying to run it on a free BSD Unix server. And open source, you can go and you can post a question out in a forum. Hopefully somebody answers you, but if they don't, what do? You got to get it running. Some companies don't like the idea of that open source software, because then who do you call when it's broke? Our server's down. Half our company can't connect. Who are you going to call? They like the feeling of being able to call somebody and pay them, and they will get you up and running. So that's why you'll see versions of Linux out there that are for sale. And they provide that technical support. Now, just talk a little bit about open source. Some different websites. Here's osalt.com. These are alternatives, open source as alternative. So osalt.com. And I like this one the best. This has the most established open source projects on it. You'll see it says 10 open source, Dia, Clonezilla. Not even sure what all these are. I don't use all those. Up here, there's a search blank here. And if I type in some kind of item there, like AutoCAD, as they indicated, it will come up, and the red is the commercial product, and the green is the open source. So Archimedes is a CAD package focused on architectural design, and sometimes I guess that's it. That's the only one out there. Then if you click that, gives you a little bit more about it, gives you the website, what it can be installed on. I guess here's some other CAD ones that are similar to it. But you can come out here and find free software. And the red is the ones we got to buy, but they show the equivalent if there is one. So pretty nice package or software that is available out here. Like I say, they only put the established ones out here. Now there's another website called SourceForge, and this has a lot more projects out here. I would almost tend to say it has every project out here, but a lot of these are not very established. Some of them are. I come here and I type Algol. That's a programming language from the 60s, 50s. I might even have trouble finding it. Software development, let me look there. There's an open source Algol 68, 1968 implementation. You can see the project. I was hoping to find one that wasn't being updated. Talks about this as a open source implementation for UNESCO's IFIP's Algol 68. I've used Algol one time. Comes down here. Gives you some reviews if there is any. Gives you project details. Gives you a lot of different information. Here's files you can download. Sometimes it's hard to see how to install it. You know, obviously it's a zip file here. Code. Some of this is new. I don't go to SourceForge very much. I don't like dealing with products that only halfway work. Somewhere there used to be in here where they talked about the last time it was updated. And I saw that when I searched for it, but I'm not seeing it actually on the page here. Oh, here, last update. I click the activity, say activity for it. They say I haven't updated the activity. What you'll find is some of these haven't been updated forever. They're not very active. And obviously this isn't very popular, 6 this week. But you can come here and you can search by categories. So if I'm wanting to find a CAD package, I can click CAD. I'm not sure why this stuff comes. I'm not really big into SourceForge. There's 3D modeling. I'll choose that. You may have noticed how many software packages there were there. Tux Paint, 2018. Maybe it puts all the new ones up top. Here's one that's creates APNG animation. I can tell what that is. It's a little bit older. 2017 is the last time I did anything with it. Here's one 2014, DIA diagram editor. Doesn't mean it's bad software. I think DIA was over in the other one. It just could be that they haven't updated it for a long time. These are very nice for hobbyists. Somebody at home. If you're gonna risk, your job performance on some of these, I probably would caution you to really explore, which ones are the good ones and which ones are a lot of bugs. I've written enough computer programs to know that there's no program that doesn't have some kind of software issue. And if you got somebody that hasn't updated anything on this site for 6 to 8 years, they're probably not going to provide any technical support for you. Somebody hadn't been on for Camp Studio, hadn't been on for a couple of years, same idea. Some of these are, I recognize these names. Some of these. Free Glut. Anyway, you can play around with SourceForge, all free software. Now, the implications of OSS, software is developed very rapidly through widespread collaboration. You can work on projects. Linux isn't written just by one person. There's a team of people that work together to make it, to evolve it, make it better. So if you want to get involved with a project, you can. That's especially good if you go into programming, you don't have any kind of experience. You could get involved with an open source project. Looks good on a resume. Versus all I did was work at this convenience store after you got your degree. Software bugs, errors are noted and promptly fixed. I'm not sure about that. That could be debated. But then again, some of the software issues in Windows packages take a long time to get fixed. Used to be Microsoft Excel wasn't written correctly. Part of the it's kind of an interaction back and forth. When you run an application software and operating system, they're supposed to work together. And Microsoft Excel originally, when you go into it and get exit out, it was supposed to free up that memory and to give it back to the operating system. Say, hey, okay, I'm done with this, you can use it. It didn't free up the memory like it should have. So if you went in and out of Excel multiple times during the day, then eventually your system crashed. It was easy at IFR where had this happen. This is about 20 years ago. They fixed it, I'm sure. I never have tried bringing Excel up and down over and over, but I assume they fixed it. But we'd have users do that, and it was easy. We'd just tell them reboot your computer and it'll work. Because when they rebooted it gave all the memory back. But again, took a while for Microsoft Excel to fix that. So the development team with them. Software features evolve quickly based on users' needs. Again, this depends upon what kind of project you have. We're talking about Linux, so yes, that is true. But some of that other software I point out to you, it's not so true. You have somebody who hasn't put a change out there for 2 years or 6 years, they're probably not going to quickly make a change. The perceived value of the software increases because it's based on usefulness, not on price. And that's probably a big one there. Not everybody could afford Microsoft Office, Word, and Excel. If you got 500 people in your company with computers, that's kind of costly if you take that amount. If you look at the licensing for 500 people for Office. So instead, they can run an open source alternative. And I couldn't even tell you what the open source alternative is to Office now, like Word and Excel. I think there used to be an Open Office, but I think it's changed names. But you definitely can run a package that does everything that Microsoft Office does. Grab another drink here. Types. Open source, software in which the source code and software can be obtained free of charge. It can be modified. If I wanted to come up with my own Linux distribution, I can get source code and I can change it and come up with David's Linux. Closed source, software in which source code is not available, although this type of software might be distributed free of charge, is usually quite costly. Microsoft Excel is an example of this. You can't get source code for it, and it's costly. Now there's freeware. Closed source software is given out free of charge. I use a package called Paint.net, and I like it better than GIMP Shop. GIMP Shop is a open source alternative to Photoshop. If you go to OSSalternative.com. GIMP Shop I had to struggle with a little bit. There's GIMP, which is the package I hate. There's GIMP Shop that's geared more toward making it look and act like Photoshop. But then Paint.net I just like because it's just a little bit more user friendly. I can really navigate it well with what I want. I don't believe it's open source. I never have seen a place where I can download the source code. I think it's just freeware. You might be saying, well, why does somebody do this for free? Why does open source even exist? Well, part of it is people just want to create a community that helps each other. So it's a good nature of people to do. Some people just ticked off at Microsoft and want to come up with alternatives and say, hey, use this instead of Excel. It's free. You don't have all the licensing issues each year, so forth. A lot of people in education, they'll create these programs, not at the community college level, more probably at four-year college. Part of a professor's responsibilities at a four-year college, just not teaching. They get in trouble if they teach too much. But part of it is research. In some cases, you're researching a disease, for example. You're talking the computer area, your research might be developing a open source package. MIT has come up with some fantastic software. Now, I couldn't tell you if it's open source or not. I think they came up with a Scratch game development software. And again, their professors, when they create that software, they basically are satisfied their research criteria. Shareware, closed source software is initially given out free of charge, but requires payment after a certain period of use. You still see those around. Now, types of open source licenses, the GNU public license, GPL, developed by the Free Software Foundation, FSF, stipulates that the source code of any software published under its license must be freely available. Users who modify the source code must also redistribute the modified code freely. You got artistic license, OSS license, allowing the source code to be distributed freely, change only at discretion of the original author. Original author has the right to reject changes. You'll see a lot of different areas coming up with this kind of free concept. Started with software. There's textbooks. There's one called licensing called Creative Commons, I think is what it's referred to. And it's where you give the rights. You put a textbook out there for free, and you give rights to people to use it. They can modify it and sell it. They can modify it but can't sell it. So there's lots of different variations of it, and that's what they're indicating here. Most closed source software is sold commercially. Usually bears label and manufacturers such as Microsoft, Apple, or Electronic Arts. Freeware, distributed free of charge. Source code is not available. And shareware, initially free, but requires payment after a period of time or for use of certain features. We'll talk about those. Well, what's the advantages of using Linux? Risk reduction. Changes in the market or customer needs may cause companies to change software frequently. It can be costly and time consuming. I think Microsoft has stated that they're going to quit supporting Windows 7 on a certain date. What does that mean? Well, if you got Windows 7, you can keep running it, and nothing wrong with that. But they won't put out any updates anymore. So that if there's a glaring security hole in Windows 7, then your entire company could be at risk. And so what are people going to do at that point? Well, they probably have to go to Windows 10 because it's supported. If there's a glaring security risk, then it's handled in theory. If you don't have that and you stay on Windows 7, then you could have a lot of issues. So again, that's costly. How much is it going to cost to take everybody in your company to Windows 10? I remember here at the college, I had an older computer, and they updated me to Windows 10 on that computer. It was horrible. It ran so slow. It was not meant for Windows 10. But what choice did they have? You leave it on the old one and potentially have hacking go on, a bunch of potential issues that could occur, or have David run his computer slow. So they chose the second option. But again, these are things you have to decide in IT because there's a limited amount of money. And I understood. I wouldn't mad or anything, but things you have to consider. Support for closed source software may end. Vendor may go out of business. Software version may be retired. And again, that's what Windows 7 is getting ready to do. OSS products offer the opportunity to maintain and change the source code. Still an issue there. If you got an old version of OSS, if it has some security issues, then you may have to go to the new one anyway. Now you must say, well, yeah, but that's free. Well, how much is your time worth? Putting down 500 machines, can be costly. But it is better than the alternative. Now, meeting our business needs, we got common software available for Linux, includes scientific and engineering software, software emulators, web servers, web browsers, e-commerce suites, desktop productivity software, graphics manipulation software, database software, security software. Like I say, you'll find all different kinds of open source software you can install. Also provides stability and security. Customers using a closed source OS must rely on the OS vendor to fix any bugs. Waiting for a hot fix may take weeks or months. I think at one point in time, I had students tell me this. I never have run out and researched it myself, but I think Microsoft would pay you if you found a security issue. Not that you hacked in and so forth, but you reported a security issue to them. So I allowed them to be a little bit more proactive when something went wrong. And so it wouldn't take weeks or months because they know about it ahead of time and they could issue a fix before they received 20,000 calls in one day. The collaborative open source approach to testing and fixing bugs increases the stability of Linux. Yeah, I'd say that's probably true. You got more eyes looking at it and so forth. Bugs and security loopholes in OSS programs can be identified and fixed quickly. Code is freely available and scrutinized by many developers. You might say, well, yeah, but they can also see the holes. You got your security loopholes there. When something happens, they can go research it and figure out how to fix it, but they can also see how to hack in. Yeah. Some people say, well, that's an issue right there. You're letting them see the source code. They know how to break in. That'd be like giving somebody the blueprints to your house or to your business. Say, hey, here's my blueprints. Yeah, it does have an issue there, but I think it's balanced by the fact that when everybody's looking at it, the other people see that issue and they close that hole. So there's that loophole. It's got flexibility for different hardware platforms, and we've talked about that. Partial list of hardware platforms which Linux can run: Intel x86, x64, Itanium, mainframe, S390. I don't know if any of those are still around. Probably are. ARM, Alpha, MIPS, M68K, PA RISC, Spark, Ultra Spark, PowerPC. I'm not familiar with all those. Linux can be customized to work on mobile and embedded devices. And that's what we're talking about, is when it doesn't consume a huge amount of memory, you have more options with it. Got your ease of customization. And I'm not sure if I agree with that necessarily, but it does allow a lot of customization. I wouldn't say it's easy. Ability to control inner workings of the operating system. To use Linux as an internet web server. Recompile the kernel to include only support needed to be an internet web server. Results in much smaller and faster kernel. So if you don't want to compute the server to do anything else except for manage the web pages, you can do that. Can choose to install only software packages needed to perform required tasks. Perhaps instead of instead of coming with all of the programs pre-installed, then it just has certain ones, and you can install other ones. Now Microsoft has moved more into that, where you add Windows features, but it doesn't have the same concept as Linux. It provides a wider range of features like that. Linux supports several programming languages, such as Shell and Perl scripts to customize or automate tasks. Perl. Shell, we're going to see during this semester. Perl is still around. I used to work with Perl at IFR, and I've taught Perl before. There was other ones out there that probably a little bit easier that might customize tasks. Python is one of them. You can do a lot of different programming languages. You can do C on Linux. I used to have a server. I think it was called MrMath.com. I have one now, MathHeals.com. But at MrMath.com, I had on a Linux server through Southwind. They were a provider in Wichita. And I was just playing, and I wrote a C program on there. And with the C program, I had it connected to a web page because I wanted to see if I could do that. I knew you could do Perl and so forth because I've been doing that. And I think I received an email the next day telling me to remove that program or they were going to suspend my account. They like scripting languages. Scripting languages allows you to see the code. It's not hidden in an executable. With the C program, it created an executable, and that left them feeling very unsure of what I was doing because they couldn't see the source code. So you'll see that scripting languages is popular on web servers because then they can research what's going on and so forth. Ease of obtaining support. I wouldn't say that's always true. I've struggled with finding help with some Linux or Unix options, but then again, I haven't done as much with Linux in terms of in a production environment. Pretty much when we got to that point at IFR, we had Linux engineers that did all the real heavy lifting for Linux. Linux documentation can be found on the internet, frequently asked questions, how-to documents. How-to documents are maintained by their authors, but are essentially collected by Linux Documentation Project, LDP. Linux news groups, Linux user groups, LUGs, open forum of Linux users who discuss and assist each other in using and modifying the Linux operating system. Cost reduction, and we've already talked about that. It's cheaper than Windows. No software associated with acquiring or no cost associated with acquiring the software. A wealth of OSS can run on a variety of different hardware platforms running Linux. Largest cost associated with Linux, hiring people to maintain it. That's not trivial. If it was easy, anybody could do it. You wouldn't need a certification. Somebody just picking up a 15-minute video could be up and running on it. It's complex. It's amazing me if you ever watch Linux boot up and you see all the different line items going across. And I wonder, what kind of person it is that understands every line item that's going across there. I could research each line item and I could tell you what it does, but just knowing to begin with, I don't. Some of it I do. Total cost of ownership, TCO, overall cost of using a particular operating system. So again, you have to balance that. Part of it is from a server standpoint, not having people hack into your server. Maybe it takes more people to maintain that Linux server. Maybe less, that might be argued. But you don't get hacked in as often. It used to be a joke at IFR. Our Windows servers versus our Linux servers. The Windows servers you have to reboot every so often. Maybe once a week you'd have to reboot it. If you didn't, it kept losing memory. The operating system, the server software didn't balance that correctly. Linux servers seem like they need to be rebooted maybe once every 6 months, once a year. It was unreal. It's just no memory leakage. It just kept on running. They still need to be rebooted every now and then because they'd have issues. This talks about cost reduction. You got your operating system costs. Linux is 0. Closed source operating system greater than 0. And I couldn't even tell you what Windows 10 is right now. That's kind of the Microsoft's big one right now. Cost of administration. This is low. Stability is high, and bugs are fixed quickly by open source developers. I agree with that somewhat. Stability is high. Like I said, you only have to reboot the server maybe once every 6 months. It just keeps on running. They're fixed quickly. I'll agree with that. Because I'm assuming it's true, they put it there. But it takes a while to implement those. It's not so easy as just running exe and you're up and running. Putting in an update may take half a day, may take a day. A closed source operating system, moderate high, bug fixes are created by the vendor of the operating system, which could result in costly downtime. That's probably true in both cases. Cost of additional software, low, none. Most software available for Linux is also open source. And I've showed you a couple of websites where you can find good open source packages. But for your closed source, it's high. Most software available for closed source operating system is also closed source. Can't see your code for Windows 10. You can't see your code for Word or Excel. They want to sell it to you. They don't want you to give it away for free. Though it's interesting, you'll find that they don't necessarily make it open source, but a lot of, there are some that make it open source, but a lot of the places that make a lot of money by selling software are providing open source alternatives, or they're providing free software that you can use. It has some limitations and so forth, but I'm not sure why they're doing it, really. They've made some pretty good money in the areas they've gone into. Oracle's one of them. I'm pretty sure MySQL is free, but let's see. Oracle MySQL, is it open source? MySQL didn't used to be pushed by Oracle. Most popular open source database. So this is Oracle has come up with this. and probably a pretty good option. So why'd they do this? Obviously, if you can use this for free, why would you want to buy their database? Their Oracle database is quite costly. It's also very robust, and they know they got such a name in the field, and such a market hold, that maybe they figure they can do this. They can put free software out there and still be fine. So it's interesting how some of the companies are changing. I don't know if Microsoft has any open source software or not. I know Oracle does. Cost of software upgrades, low, none. Again, you have somebody maintaining it. It's not free. Closed software is eventually retired, and companies must buy upgrades or new products to gain functionality and stay competitive. Now this is, I know, not that exciting. A lot of definitions here. It'll get more interesting as we get into the commands and some of the different aspects of Linux. It talks about the history of Linux. You see, I claimed that I didn't start seeing it till, well, I didn't say the date, but I suppose it was in the 1990s. But you see here, the history of it goes back to 1965. Then the creation of Unix was 1969. Again, it was originally called Unix. I don't think I was even the Multics. I don't think I did anything in that sense. Then again, MIT jargon file released. I'm reading that correct? It gets over to here, and this is probably I probably used it in the late 80s in college. And then the 90s is where I worked with it more. And you see, this is where, I'll probably really butcher his name, Linus Torvalds, I'm saying the name right, creates Linux. And then you got rapid Linux development here, and worldwide adoption of Linux technology, so just that's kind of replace it. You don't even hear the word Unix that much anymore. I put that there just to kind of maintain the connection to the past in the course title. But Linux is pretty much what everybody refers to it as. Grab a drink here. Oh, were you? Oh, yeah. I mainly just use it. I guess in college and in the workplace. So you used it kind of just learning. Oh, okay. Yeah, I like Linux. I'm not sure if I'm that crazy about the GUI side of it, but I suppose that's because I learned the command side. No, that's kind of the new evolution, which will take the users, because it makes it a lot more user friendly. They can actually use it. The Unix evolved from multiplex to information and the computing surface, Multics. First true multitasking, multi-user operating system. That might be true. I don't know. I might disagree about that. I don't know when the mainframes came about. They were supposed to be multitasking, multi-user. They say the first true one, so I'm not sure what they mean by that. I worked with a Unisys mainframe, and they were back in the 60s. I don't know. I debate that, but again, I could hang up the entire mainframe with one application. And I've done that before. I did that before when I was at Coke. And they tell me don't do it again, whatever I was doing. So that's not truly managing all the users when it can do that. Unix was rewritten C programming language. Portable operating system able to run on different hardware platforms, and again, that's a kind of a big thing there. And then AT&T sold the Unix source code to several companies. Each developed its own variety or flavor of Unix, yet adhered to standards agreed upon by all. Then we got our Berkeley software distribution, the BSD, the version of the original Unix source code. FreeBSD is what I used back then. That was the little devil software. They had a little devil mascot, and that created some controversy there. Though they had fun with it. Now, common flavors of Unix today include Oracle's Solaris. And again, I don't think that's free. I think that paid for that. And then that was formerly Sun's Microsystem. HP UX, again, I don't think that's free. It might be. IBM's AIX, Unix, Apple's Macintosh OS X, and iOS. That's probably not a, we're about out of time, so that's not a bad place to stop. So we'll continue next time on that. And now that I got the software working from Cengage, what it has is a little virtual lab, so you can use that. Did you have any, no assignment yet on that besides just the introductions discussion. Did you have any questions, Jesse? Mostly, and then some quizzes and tests based upon the readings and so forth. But they will be open note at home, so you can refer to your notes and so forth. Oh, okay. Pretty much whatever I assign during the week, we do the following Sunday. But if you do find you need a little extra time on something, just let me know. If I know you're actively working on it, then I'll work with you on the due dates. Okay.